Hello, and welcome back to the second episode of my Bevy version 0.6 tutorial series. When we left off, we had created a window, a camera, and drew a sprite on the screen. Now in this tutorial, we are going to add movement to our character, create a tile map, and handle collisions. We will cover more of Bevy's ECS, and create our own components, and learn how to use basic queries to get entities in our systems, while organizing our code into plugins. We also clean up some of our code to make it more usable as the project grows, as well as covering some basic debugging in Bevy. As always, you can see the current work on the final product of this tutorial series on the GitHub link in the description. The first thing I want to do today is clean up our main file and move the player to its own file. Now is a good time to cover what a plugin is and how we can make our own. In Bevy, a plugin is just a way to break our app builder out into separate, more manageable modules. For example, the default plugins adds the input plugin, which gives us many systems to handle mouse, keyboard, and gamepad inputs. The order plugins are added to the app sometimes matter, as some depend on resources to have already been added to the app. Like if you add the default plugins before the window descriptor, then you would notice it had no effect because the Windows plugin checks for the descriptor on build. To create a plugin, all we need to do is define a public strut and impl plugin for it. To impl plugin, we just need to define a build function, which will give us a mutable reference to the app, and add the systems to it just like we were doing in main. I'm going to move the spawn player function to this file, and move the add startup system call to our new plugin. Now we need to remember to add this plugin to the app builder in main. Unfortunately, this will not trigger a dead code warning, so remember to double check that you've added your new plugins to the app. One last bit of cleanup I want to do is to start using cargo clippy to check the code. But I want to allow redundant names like height because I like the symmetry of the code more than the compactness, so I will allow that in main. Now it's finally time to handle input and move our player. First, we need to make the player a bit more unique so we can find it out of all the entities we will have in our game. Right now the player is exactly the same as any other texture atlas sprite. The easiest fix of this is to design our own component. Remember, components are the data in ECS, where our player entity is just an ID to associate components together. To create a component, we just need to create a strut and impl component for it. Thankfully, Bevy provides a derive macro for components, so we just need to put the derive component statement before our strut. Now when we spawn the player, we can insert our player component. Now it's time to make the movement system. We create a function player movement, and for the first parameter, we need a query for our player. A query in Bevy is the system function parameter we will use to look up groups of entities by their components. Here we want the entities that have the player component and a transform component, and we want to mutate the transform. It's important to note that the parameters here should be references and must be a tuple. If you forget the tuple parentheses, you'll get a weird error on compile. We also want to get keyboard input in this function, which we will do by accessing the input resource of type keycode. This will let us see which keys are pressed and if they were just pressed or just released. Now we can write the system. We can get the transform out of our query using a pattern matching let, and because there's only ever one player, we can call playerQuery.singleMute. If there's ever 0 or more than 1 matches to our query, then the game will crash, so this is a little risky, but it should be safe for our game here. If you want to do the error checking yourself, you can call getSingleMute, which will give you a recoverable error on 0 or more than 1 matches. Next, we check if each of our controls is pressed and change the translation accordingly. This should work, but it has one major bug. It's not frame rate independent. If we want the player to move at a constant speed across different frame rates, then we need to multiply the movement by the time between frames. In Bevy, we get this from the time resource, and specifically, we want to call delta seconds to get the exact time since the last frame. It's important to use Bevy's time for updating, because other methods of getting the time may be inaccurate. Check the cheat book for a description of this. Alright, let's do some more cleanup. First, we want a better way to adjust the player's speed, so let's add that as a field to the player component and adjust our movement to use it. We also want to make the player much smaller, so let's make a global constant tile size, which will let us rescale the game easily in the future. We will make the player and its background that size and adjust the movement to be relative to it, so we'll get the same behavior at all sizes. Now is a good time to add a core debugging feature of the Bevy ecosystem, the Inspector eGUI. This is a very customizable tool which will let us see what entities are in our world and what their components and data are. We will add this to our cargo toml file, and then I'm going to create a new file and plugin called debug plugin, which will hold everything we don't want in release builds of our game. Here I'm going to add the world inspector plugin to get our debugging overlay, and I'm going to use a Rust trick to check if you're in a debug build and add the plugin only then. Now we have an inspector we can use to poke and prod the entities in our screen. We also want to register our player component so we can see its values and tweak them. We just need to derive inspectable on the player and register it in our debugging plugin. We will cover more features of the inspector as we go on. Finally, as one last bit of cleanup, I want to move our ASCII loading function to its own file and plugin. Here I want to turn the ASCII sprite creation into its own function, which will need commands to spawn the entity, our graphics handle, the index of the sprite to spawn, a color, and the translation to spawn the image at. And we will return the newly created entity so more things can be added to it in the caller. Now we just take that code from our player creation and clean up the player spawn script to call our function for the player in background. Now let's make sure we've added all of our plugins to the main builder and run the game again. Next, let's create a map for our player to move around in. I'm going to create another new file and plugin called Tilemap plugin and add it to the app builder. You probably don't need this many plugins, but it's a nice way I've found to keep all of one set of functionality in a single file when using Bevy. Here I want to create a startup function to spawn our map. I want to define my maps in external files, and right now the easiest way to do that is a plain text file. Now let's do some simple Rust file reading here. I'm going to iterate over all the lines of the file, and then each line I'm going to iterate over the characters. I'm going to assume the text file is in plain ASCII and create a sprite for each character in the file. I'm inverting the Y position so the file will spawn top down. Note I'm using blocking file operations instead of the asset manager here. If your file was more sophisticated or you wanted asynchronous loading, then you could create a custom asset loader for it. I'm going to change our player starting position so it's offset inside the map for testing. Now we have a nice looking map, but it's just sprites with no collision. Before we add collision though, let's clean up our inspector view. We want to create a parent to hold all of the tiles. So let's collect all of our new tiles into a vector, and at the end of the file parsing, we'll create one more entity named map, and push the tiles as its children. One important thing to note when creating parents like this is we need to add the transform and global transform components to the parent. This allows the built-in systems to propagate the transforms down and render our sprites at the right place on screen. Without this, all sprites will appear bunched up in the center of the screen. Now we can see our inspector is much prettier and more usable. Finally, let's add collision to our tiles. I'm going to create a new component called Tile Collider, which will mark which tiles the player should collide with. And I'm going to add that to every tile that's created from a pound sign in our file. Now in the player movement, we want to query for the tiles with colliders. We could add this as a separate system, but then we would be doing and undoing the player movement, as well as having to worry about ordering. There are many ways of doing this, but this way works for us, and for future features like doors, we will handle that in separate systems. One important note here is the game will currently crash on running the system, because the player could have a tile component which would make it match two queries. Bevy does not allow this and will crash even if we know the queries do not overlap. Thankfully, this crash gives us a nice message telling us how to fix this. We can add a second parameter to the query to tell it to exclude entities with certain components. This parameter can also be a tuple, and because we aren't using any of the data on the collider, we can make it a with constraint. Now our game won't crash when running the system. To actually perform the collision, we're going to test if the result of the player movement would cause a collision and reject it if that's true. This has some flaws, but they are minor, such as the player won't press completely against the wall. We can upgrade this to a better collision system in the future if we want. First, let's create a function to use a target player position in the wall collider query to determine if we will collide. We iterate over each wall transform and call the built-in Bevy collide function, which will check if two axis-aligned rectangles will collide. This is on the chopping block to be removed soon, but hopefully it will come with a better Bevy physics engine. I'm going to make the player's hitbox slightly smaller than one tile to help the player navigate one tile wide spaces easier, and this will deal with some of the problems of our collision method. Now we just return false if there's ever a collision detected. Back in the movement function, we can test X and Y movement separately against this function, which will let the player slide along walls even if one axis of movement is impossible. As a final cleanup, we will add a system to make the camera follow the player. First, we want a query to get the transform of the entity with the player component. Note this is not a tuple, and we are using the second query generic parameter again. We also want a query to get the camera transform mutably, and this time we will add a without player constraint to prevent query conflicts. Now we just call single and single mute on the queries as we are confident there is only one of each and both must be present. and we want to set the X and Y of the camera translation to match the player translation. We add the system, and now the camera will follow the player. There's one subtle bug here, where the camera movement and player movement are happening in a random order, so our behavior will not be consistent and may jitter. We can fix this with explicit ordering of the camera and player movement, using a label on the player movement system, and an after call on the camera system. In this tutorial, we learned how to make our own components and how to query entities in our systems. We also learned how to handle input and some basic tricks to handle query conflicts. Now we have a map loaded from a file that the player collides with and a camera following the player around. Next time we will cover basic state management and events in Bevy to create wild encounters as the player moves around the map. As always, please remember to subscribe and leave any feedback in the comments below. Thank you for watching.